A tethering rig constructed at Holloman Air Force Base, New Mexico, was used to suspend the F-102 airplane for further testing of the MB-1 missile. The 1781 airplane is one of 3 F-102s assigned to this project. For the tests, this airplane was stripped of all non-essential equipment and the engine removed. Pneumatic and electrical power to the airplane was supplied from remote compressors and generators. Actuation of test instrumentation and the firing system was accomplished by landlines. The 1781 is fitted with a pylon to which the missile is attached. This is not standard equipment. The F-102 in operation carries all armament internally. Testing of internally carried missiles is to be included in the complete test program. The first firing occurred on April 10, 1956. Between firings, the F-102 was lowered for examination. On April 14th, the second MB-1 missile was fired from the test rig. The MB-1 is the largest solid propellant missile to be fired, developing a thrust of 37,500 pounds. Both firings proved the airplane-to-missile relationship satisfactory. Visual examination of the F-102 revealed no significant effects of blast pressure or temperature. Data for complete analysis of test results was obtained from oscillographs, telemetering equipment, internal camera coverage, and FastX range instrumentation. Following the tests, the F-102 was restored to flight status, and preparations were made for the first airborne firing of the MB-1 from standard F-102A missile launchers. During the latter part of March 1956, Convair's F-102 engineering flight test operations completed the move from the old site to a newly constructed facility approximately 4 miles north of this site. This area is located at the Air Force Flight Test Center under construction at Edwards Air Force Base, California. Expansion of the F-102 program necessitated this move to a more adequate facility. The abandoned hangar will be utilized for other purposes. Central structure of the new area is a 200 by 600-foot all-steel hangar. This central structure is flanked on either side by smaller buildings, each 40 by 200 feet, affording adequate space for operations associated with the actual engineering flight test operations. The hangar has space for 10 airplanes at one time, in addition to the equipment which must accompany this operation. Parking facilities for 250 cars are located adjacent to the area. One of the smaller buildings will house administration and engineering offices. The other is a combination warehouse and material stores building with added space for fabrication, equipment, a garage, and maintenance work. Centered in the main structure is a 2-part mezzanine to house field operations, instrumentation, security, and other offices. This can be removed if additional hangar space is needed. Concrete aprons extend from either end of the building, and taxiways link the area with a 15,000-foot runway. The new facility answers a long-felt need for this phase of the complete flight test program on the F-102. The entire area is fenced for security purposes. At Palmdale, California, interim hangars built to meet the overflow from Convair's Flight Test Center are now being utilized. This area is located approximately 1/2 mile from the present site of the Flight Test Center. The two areas are connected by runways. F-102As and more recently TF-102s are brought to the Palmdale facility for testing and preparations necessary before their acceptance by the Air Force. The initial deliveries of the F-102A airplanes to the Air Force was recently accomplished. Construction of the new facility, 4 miles from the one now in use, had progressed to this stage as of May 25, 1956. Paving, installation of utilities, and construction of miscellaneous buildings was better than 50% complete as of June 1st, 1956. Construction on the initial building, designated Building 301, was approximately 60% complete as of the June 1st date. A temporary delay in construction was caused by a jurisdictional dispute between steel workers and sheet metal workers over installation of metal siding. First to move into the new central structure will be Convair's electronics section, now located at the Lockheed facility nearby. The F-102 flight test program is expanding to meet increased production of the F-102. Long-range planning for meeting plant area requirements is keeping pace with the expanding F-102 program. At Convair's San Diego plant, work on F-102 flyaway stations was approximately 80% complete as of June 1st, 1956. The new area is located adjacent to a 4-station facility presently used in this phase of the F-102 program. F-102s and the TF-102s are towed from final assembly lines to this area for fueling, oiling, green engine run, and maintenance procedures prior to flight to the Production Flight Test Center at Palmdale, California. 11 new stations being added will bring the engine run-up stations to a capacity of 15. Present plans call for expansion of the F-102 program to triple the rate of present production. The new facility includes a small hangar, which will be used for maintenance work on the F-102. This hangar will provide adequate space and equipment for engine removal and servicing. Operations offices are a part of the construction. Space will be utilized by Air Force inspection, engineering personnel, and pilots. The concrete apron will be used for parking airplanes and for minor maintenance. 5 spaces are provided for airplanes that are ready for release to the Flight Test Center. Tentative plans of the field operations section have been set up with provisions for addition of sound suppression concrete block housings. At the San Diego division of Convair, manufacturing was begun on the airplane presently termed the F-102B. Fuselage construction includes 4 sections, 2 of which are being manufactured as test stands. One of these will serve as a power plant test stand. The other, more detailed, will include wing and fin components and will be used as a control systems test stand. This is being done to simulate as closely as possible the actual airplane in order to obtain better dynamics charts in test procedures. The remaining fuselage sections, upon completion, will become the prototype flight models of the new airplane. The design of the fuselage sections includes a smaller cross-sectional area. Vertical fin and air brake area has been increased. Air intake ducts on the new models have been placed further aft. The intake duct features a variable ramp for better flow characteristics at various Mach numbers. Variable ramps are controlled by the air data computer built into the 102B prototypes. Redesign of the cockpit has centered around the inclusion of the Hughes MA-1 unit. The canted bulkhead is further forward. Provisions have been made for the basic side stick configuration with kits and installation procedures for mounting a center stick. Present plans call for use of the J-75 turbojet engine. Built to withstand very large loads, the wing, built in 2 sections, is essentially all fuel tank. Like the fuselage sections, major assembly fixtures are aligned through the use of optical tooling. By this method, extreme accuracy in the duplication of aircraft assemblies is possible. Upon completion, the 2 wing sections will be mated in this jig. After alignment of the major assembly fixtures, the 2 sections will be placed into position and moved together for mating. A full-scale test rig is under construction for proving 102B fuel systems. The rig will be used to simulate flight conditions. Wings under construction include one for this testing phase, as well as for the prototype models and control systems test stand. Delivery of wing sections for mating to fuselage is scheduled for the latter part of August 1956. In another plant area, production activity on the F-102A continues at an increasing rate. Through long-range planning, it is expected that at the height of production, F-102A release will triple that of present production. In early tests of the TF-102, pilots encountered airplane buffeting in the limited Mach range of 0.83 to 0.90. Convair's San Diego pre-design and aerodynamics sections, working jointly with engineering personnel of Convair's Fort Worth plant, set about to solve the problem. Engineers discovered that rapid curvature around the side-by-side canopy created supervelocities of such magnitude that separation occurred once the air decelerated to stream velocities. Tuft flow studies showed the separation areas where vortex generators on the original canopy design should be installed. A single row of generators was placed on the forward frame of the original canopy configuration. Considerable reduction of buffet was accomplished. The tests also revealed how a cut-down canopy could be shaped to reduce these local velocities or negative pressures which caused the shock separation and consequent buffet. As a result of these studies, two possible solutions were presented: modification of the original canopy by adding vortex generators, or redesign of the canopy. Further investigations resulted in placement of a double row of 1-inch high generators on both the original canopy and the cut-down canopy. Extensive Air Force flight evaluations were made on the two canopies. For all practical purposes, the cut-down canopy, with the addition of the two rows of generators, was found to be buffet-free. The original canopy, with a similar installation, provided for buffet reduction to a point which no longer constitutes a flight problem. The Air Force decision was in favor of the original canopy configuration with the double row of vortex generators. Factors involved in the decision were the better visibility of the original canopy and the loss of time and expenditure that would be necessitated in retooling to the new canopy for production models. The first Delta Wing supersonic all-weather F-102A interceptor to be delivered to a United States Air Force squadron rolled out of its hangar at Palmdale, California, May 1st, 1956. This is number 1 of scheduled deliveries to the 327th Interceptor Squadron, making it the initial F-102A equipped Air Force squadron. Lieutenant Colonel Charles E. Rigney accepted the interceptor for the Air Force. Commanding officer of the 327th, Lieutenant Colonel Rigney, received a last-minute checkout from Convair pilot Rex Warden before taking off for the 40-mile flight to George Air Force Base, Victorville, California. In anticipation of the delivery, Convair field teams had been sent to George Air Force Base to train personnel in the operation and maintenance of the 102As. The Palmdale facility is Convair's production flight test center. F-102s, manufactured at Convair's San Diego plant, are brought to this location to be performance proven before their acceptance by the Air Force. It is from here that future deliveries of the F-102 to Air Force squadrons will be made. Under the Cook-Craigie aircraft procurement plan, the F-102A deliveries will be made with increasing frequency. The F-102 is 68 feet long, 18 feet high, with a wingspan of 38 feet. It is powered by a Pratt & Whitney J57 turbojet engine with afterburner. On the delivery flight, the F-102A was well beyond George Air Force Base at 35,000 feet by the time the gear was up and the pilot squared away. During the flight, the interceptor exceeded the speed of sound twice, both times unintentionally. Her pilot was enthused over the 102A's performance. At George Air Force Base, Brigadier General James W. Andrew was on hand to welcome the Air Defense Command's new and lethal weapon. Members of the 327th Squadron crowded around the airplane for a close examination. the F-102A was received with a great deal of interest. The new F-102A became a full-fledged member of the 327th Interceptor Squadron with the application of the squadron insignia. This ceremony is the climax to years of work and study. With production stepped up, more and more squadrons of the all-weather jet interceptors will be activated until the Delta Wing supersonic F-102 becomes a familiar sight, primary part of America's Continental Air Defense Command.